All right, this section 10.3 is going to cover operations with radicals. And we're going to also review the exponent rules because you need those. All right, so if we start, this did not do what I wanted it to do, but that's okay. If we start, you're going to multiply. You can multiply whatever's under the radical together. So we could do right here, 4 times 25 gives us 100, and the square root of 100 is 10. That's one way to do it. Another way is to simplify first. The square root of 4 is 2. The square root of 25 is 5. 2 times 5 is 10. Does not matter which order you do it in. All right, let's look over here. Cubed roots work the same. As long as the index matches, you can follow this rule. So we have a couple choices. We can do 8 times 27, which gives us 216. Then if we use our little table over here, well, this one's not quite big enough, but if there were another column, 216 would be right here, telling us that the cubed root of 216 is 6. The other option would say, hey, the cubed root of 8 is 2. And the cubed root of 27 is 3. And 2 times 3 is 6. Those are just some shortcuts to do it by hand. So let's try these. 5 times 20, because these don't have perfect squares, we have to multiply them. So 5 times 20 is 100. Square root of 100 is 10. Next one. Negative 3 times 9 is negative 27. And using that chart, cube root 27, 3. So we would say it's negative 3. All right. This one here, 4th root. So we're going to multiply. 1 times 1 times 1 is 1. 9 times 3 is 27. Times 3 is 81. We're going to do the 4th root of that. So 4th root, 81 is 3. So this would end up being 1/3. All right, here, x to the first times x cubed. From the last chapter, we can add the exponents, so we'd get a 4. If we were to rewrite that as a fraction, we'd have 4 over 2, and 4 divided by 2 is 2. Now let's look at this one. Same thing. We're going to do 2 times 5, and we get 10. And then a times a is a squared. And that's as far as we can get it, unless we want to have decimals or fractions. So that would be fine in exact form. All right. Here, we can multiply 11 times xy is just 11xy. And that's as far as we can simplify that one. All right. We got one more. 2 times 16 is 32. X times y is xy. On the bottom, y times x is the same thing, xy. So now we bring our 5th root. Well, looking in here, the xy is going to cancel because we have the same on the top and the bottom. So the 5th root of 32, if I go back to my table, 5th root, 32, 2. Shadow stop. Sorry, my dog's having a moment, as per usual. All right. Now that we have those, we can simplify numbers. Sometimes they don't come out perfect and you're told to simplify. So what you're going to do is you're going to find a perfect square that goes into it. For example, 300 can be rewritten as 100 times 3. You can break that into 2 radicals. Well, the square root of 100 is 10. And then radical 3, we can't get any smaller. So now that's simplified. Works the same way when we're talking about the cubed root of 16. We're just looking for a cubed root that I can break up. Why is this being weird? We're just looking for a cubed root that I can break up. So 16 is not here in the cubed, but it is divisible by 8. So I can rewrite this cubed root as the cubed root of 8 times 2. And then the cubed root of 8 is 2, according to my chart. And we leave the other 2 inside. Okay, we're back to square roots for the 54. 54 is not in our list, but it is divisible by 9. 54 is the same thing as 9 times 6. The square root of 9 is 3. We have a 6 left. Let's look at 512. Again, not in our list of fourth roots, but it is divisible by 256. So it's the same as saying 256 times 2. The fourth root of 256 is 4. So 4, fourth root of 2. Now, I've done these. I have some of them. If you don't know, you can always test it by dividing. Maybe you do 512 divided by 81. You don't get an even number. Just try them. See how you do. All right, here we're going to break it into 25 and x to the 4th. Square root of 25 is 5. We can rewrite this as 4 over 2, and 4 divided by 2 is 2. All right, let's try this one. We have 32, and we have n cubed. Well, 32 doesn't have a square root, but 16 does. So we can rewrite it as 16 times 2, which square root of 16 is 4. Leave the 2 inside. Then we do the n cubed. So one way to do that is say, hey, it's 3 over 2, so we have 1 whole, blah, blah, blah. Or we can say, well, n cubed is the same as n squared times n. The square root of n squared is n. Leave the other one inside. And then we combine those. 4 times n is 4n, and 2 times n is 2n. So I'll show you that again because it can get a little bit confusing, especially where it's little like that. So we're breaking this 32 up into 16 times 2 and break the n into n cubed times n to the 1st. 2 plus 1 is 3. That's why we can do that. Square root of 16 is 4. Square root of n squared is n. Now we're left with 2n on the inside. So that's another way to think about it. You're just simplifying each part as far as you can to get into the next thing. So now let's look at this one. Cubed root of negative 16, cubed root of x to the 3rd, and cubed root of y to the 5th. Well, 16 is negative 8 times 2. Cubed root of negative 8 is negative 2. Leave the other one inside. 3 over 3 reduces, so we're just x. And then here, 5 can be rewritten as y to the cubed y squared. And I just choose that because I know these are going to cancel, and then I leave the y squared on the inside. Now I take everything that's on the outside, and I write that together. And then I take everything that's on the inside and keep it on the inside. That's another way to simplify. All right, if I look at this problem here, first I'm going to multiply. I'm going to say, hey, 2 times 4 is 8. A to the 1st times a to the 2nd is a cubed, and we only have one b. Now we're going to take the cubed root of that. Well, the cubed root of 8 is 2. The cubed root of a cubed is a, and there is no b cubed, so we're just going to leave the b inside. So there's a couple different ways that you can do it. You can do it piece by piece and write it all out, like I did here. You can do it piece by piece and break the y's apart, or you can just do it one thing at a time without having to write it out separate. It really depends on what works for you. All right, here, simplify, then put in radical notation. Now notice on this first one, this index is 2, this index is 4, so we can't multiply yet. We have to go back to our exponent rules. This first one is 5 to the 1/2. This one is 5 to the 1/4. So now I can add my exponents, multiply this by 2, and we get 2/4 plus 1/4 is 3/4. Now we put it back into radical notation, where we have 4, the fourth root of 5 to the third. All right, let's look at this next one here. 2 to the 1/2, and then 4 to the 1/3. We don't have the same base yet. 4 is the same as 2 squared. Do you agree? 2 times 2 is 4. So I can rewrite that as 2 squared to the 1/3. Then we can multiply these exponents. So we get 2 to the 2/3. And now I can add them by multiplying this by 3. I get 3 over 6. Multiply this by 2. I get 4 over 6. Add those together. We get 7 over 6. So we have a 6th root of 2 to the 7th. All right, same thing when it's a variable. We're going to say x to the 1/3 times x to the 1/4. Multiply this by 4, we get 4/12. Multiply this by 3, we get 3/12. Add those together, we get 7/12. And then we just put it back into radical form because that's what the directions told us to do. Here, again, break the top and the bottom separate. Square root of 4 is 2. Square root of 9 is 3. There we go. Let's keep going with our fractions here. We're going to break cubed root of 5 over cubed root of 8. Cubed root of 8 is 2. And we're done. As long as you don't have a radical on the bottom, you're done. So let's look at this next one. We have the 4th root of x over the 4th root of 16. If I use my table, 4, we go from 4, 16 to 2. So the 4th root of 16 is 2. So this becomes 4th root of x over 2. All right, let's do this next one. Root 16 over root y squared. Square root of 16 is 4. Square root of y squared is like saying 2 over 2, which equals 1. So we have 4 over y. All right, here, there's 2 ways you can do this one. One is to simplify first. So our top is 4 times 10, which gives us 2 root 10. And then bring the root 10 over. And when you have the same thing on the top and the bottom, it cancels, so you're left with 2. The other option is to divide first. 40 divided by 10 can be put back in the radical. We're reversing what we were doing up here. 40 divided by 10 is 4, and the square root of 4 is 2. So you get the same answer whether you do it piece by piece or all at once. Same thing here. Cubed root of 2 doesn't go anywhere. Cubed root of 16, we would do 8 times 2. Cubed root of 8 is 2, leaving the other. This becomes 2, leaving the other one inside. Those are going to cancel. We have 1/2. Our other option was to combine it, which would bring this down. 2/16 is 1/8, which becomes the cubed root of 1 is 1, and the cubed root of 8 is 2. So you still get 1/2. When you're dealing with letters or just variables and you don't have numbers, you're going to want to combine them and reduce as much as you can. So those y's are going to cancel. And then we say, hey, x squared, the square root of x squared is like saying 2 over 2, which is just x. So there's a couple more. They get a little more complicated, but see if you can do them. Pause the video, check it out, do what works for you. All right, here I'm going to break it. So we have x cubed, we have 16, and we have y to the 4th. 4th root of 16 is 2. 4th root of y to the 4th is y. And then there's nothing I can do to reduce this one. So since we're leaving it in radical notation, we'd write it like that. All right, next problem here, we multiply. 5 times 5 is 25. A squared times a to the 3rd is a to the 5th. And 8 times 2 is 16. That's all in a radical. Now we can break it. Square root of 25 is 5. Square root of 16 is 4. A to the 5th. So we have a couple choices. One, we could say, well, that's 5 over 2. And 5 divided by 2 is 2.5. So we're taking 2 out, and we're leaving 1/2 as a fraction, which we would rewrite as a squared square root a. A to the 2, a to the 1/2 would be rewritten like this. The other way we do it is we say, well, it's a2, a1, and then we're taking out 2 of these. That's why there's a squared there. Either way, this is our solution. Okay, here we have the same radicals, so we're going to multiply. X minus 3 times x plus 3. If I FOIL this, I get x squared plus 3x minus 9. Combine like terms, x squared minus 9. And that's all I can do. There's no way to reduce anything else. This one, we have an x squared in the top, so we're going to tic-tac-toe. 1, 3, 2. 2 times 1 is 2. So this breaks into x plus 1 and x plus 2. We can break the top part into a multiplication problem, so we can have the x plus 1 under one root, the x plus 2 under another one. Now our x plus 1s are going to cancel, so we're just left with the cubed root of x plus 2. There's a lot of little nitty-gritty steps, but it's just following those rules and doing whatever you need to do to be able to simplify as much as you can. Let me know if you have any questions. That's 10.3.